Welcome to Advanced Java Programming at Portland State University. In this screencast, we're going to finish up our discussion of web programming with Java. We're going to focus on how you can use Maven to build web applications with Java, and then we'll talk about REST, Representational State Transfer. So as you saw in the previous screencast, you create these web applications that are deployed as WAR files. And as you can imagine, there are several steps involved with creating one of these WAR files, one of these web applications. You have your source code that needs to get compiled, things like your servlets, and then all of your application code that supports that. Then you need to take all those class files along with any third-party or additional jar files that are out there, your static web content, your HTML pages, your images, all that good stuff. Put it all into one of these WAR files, and then you need to deploy it into one of these web containers so you can run it. Now, luckily there's good support in Maven for doing all of this because, well, you're not the only person writing web applications out there in Java, and so it has several tools to aid you in that. To get started with a Java web application, there is an archetype that you can use to get started. You can use archetype create, and you can use the artifact with the ID Maven archetype web app, and then you give it your group ID, your artifact ID, etc., etc. So this is not an artifact. This is not an archetype that I created. It's an archetype out there in Maven land. So when you create one of these guys, what do you get? Well, you get a Maven project that is configured to build a WAR file. So if you look at the packaging tag in the pom.xml, it's not jar, it's WAR. It gives you, it follows the same Maven conventions for directories for source and test code. And for files like webxml and other things that end up in that webinf directory, those all go in source main, because it's part of your main application, web app. So that's where all of that stuff is. And the package phase knows to, instead of just creating a jar file, create a WAR file in the target directory with all the stuff that you have there in your source main. If your web application includes something like a servlet, which it most likely will, then your POM needs to depend on the servlet API so that you can put the classes in Java X Servlet on your compile time class path. So you'll have a dependency something like this. The artifact ID for the servlet API is servlet-API from Java X Servlet. You want version 2.4 or later. Just like any other Java source code for your main application, the servlet should live in source main Java. So Java has built-in support for creating web applications, for generating WAR files, and it has standard places for putting all of the configuration files and additional information, such as the webxml and all of your static content, and bundling it all up in a WAR file. But another thing that Maven's good at is running web containers. At least web containers for during development or during test. Probably when web applications are deployed for real, you have a web container running out there. It's probably fronted by Apache or something like that, so that that's ultimately then served up via the external internet. But while you're developing your application, you want to be able to run a web container locally, and you want to be able to do it fairly easily. So there is a web container called Jetty, which was designed to be small and embeddable, and Maven has really good support for working with Jetty. Now, we're going to be looking at a lot of XML. I'm going to skip over. Well, I'll run through this stuff as opposed to walking through this stuff. You can read all the details online. The Jetty Maven plugin is well documented. But as far as what you'll be working with in class, I'm going to provide you an archetype that will create a nice Maven application that has Jetty all configured and also has some other stuff for nicely configured for doing integration testing with for your web application. Because here again, what I want you to focus on is building your applications, not learning about all the details of Maven so that you can configure things to work just right. Here is some XML that will configure your Maven project to have Jetty run on port 8080. So there is a Maven plugin for Jetty, and you want to configure it for a couple of things. First, you configure what's called a connector, which is basically a port that that Jetty listens on, and you want to port 8080. 8080 is the default port for Java web applications. 80, of course, port 80 is of course the default port for HTTP. By putting on 8080, it means that you're not using a low port on well, most operating systems now, even Windows. I think port 80 is reserved, and only certain users with certain permissions can open up a port on port 80. So anyway, so it uses port 8080. And you also define something called stop key and stop port, which is where the Jetty stop command will what it'll use to connect to the to the server to stop it. Okay, so that's configuring the Maven Jetty plugin. It also has some goals for doing things with Jetty. So if you say Jetty run, that will rebuild your project. So it'll compile your source code, create your WAR file, start up Jetty, and deploy the web application to Jetty. Also has something called run exploded, which will, well, here again, we'll rebuild the project, create the WAR file, run Jetty, but it'll deploy it in such a way that if you make changes to the classes or to the static content, you can do what's called a hot redeploy, which it'll pick up the changes quickly, and you won't need to worry about having to redeploy your WAR file. This is really good during development when you are evolving your application quickly. Run WAR will again do hot deploy, but it requires that you rebuild the entire WAR file before it'll deploy. Anyway, you can read more on this stuff at that URL. So that's Maven. And actually, well, we saw a little example of that in the previous screencast, but let's just quick go back to it. So if we run Maven Jetty run, you'll see that it's starting Jetty. And now when you visit localhost 8080 in your web browser, localhost 8080, it'll, well, actually it gives you a 404 because there is no application deployed to just the root file. But instead, Jetty tells you, hey, there wasn't anything at this URL. Did you mean /web? And the answer is yes, I did. And now you get here, which is the what I think is the landing page for the web application, for the web application named Web. You didn't see me just do the air quotes there. It was awesome. Okay. So I want to spend a little bit of time talking about the various methods, various verbs for HTTP. So now a GET will just request a resource. And remember how we said that HTTP request has a first line, then it has all of the header key value pairs, and then it might have an optional content, an optional message associated with it. Well, put, post, and delete the definition of those verbs. The content means something. When you're putting or posting, you're sending information to the server. Delete can also include content. Get, on the other hand, the request, the only content there is the URL being requested. If there isn't supposed to be data sent with get. If you want to send data with get, you can put them in query parameters, right? So as we saw here is a Google search, which will take a language and a query string. Now, when you put data in the URL, you need to URL encode it, meaning that there are special characters. Well, actually, there are some characters that are not meant to be in URL. So, for instance, you can't have a space in a URL, right? If you want to have a space made as a query parameter, you need to encode it using URL encoding, and so a space would be encoded with like /20 or something. Now, if you're putting together URLs in your Java code, and you want to make sure that everything's encoded properly, there is a class called URL encoder that has methods that will encode some string using the URL encoded MIME type. So, for instance, when you've got query parameters to a URL, here's an example of how to do that in Java. you start out with your query, and then here, I don't know if I show the source. Let's check the next slide. Yeah, we'll see on the next slide that there's a method called Encode Parameters. It takes all the parameters and puts it together in a string builder. And if there's actually something there, it will append the prepend the query with a question mark, and then add that to the URL, and then open up the URL connection and create one of these new response objects. Note that this code is from this HTTP request helper class, which is a class that I wrote to making HTTP requests a little easier. It's also available to you for your project, and in class we'll look at the details of that project so that you can see how this class can be used. Here is a method for encoding the URL parameters. Basically, the parameters, we expect this to be an even number of arguments in this variable length argument. So what we'll do is we'll iterate over each key value pair, which are just consecutive arguments in the parameters list. And then we will URL encode the key, have it be equals, URL encode the value. And if we haven't reached the end, then we'll put an ampersand between them and return that. So this does the job of encoding the parameters. Okay, I want to spend a little bit more time with this class because here again you'll be using it in your assignment. So if we go back a couple of slides, the last thing that our get method did here is that it returns a new response given the URL connection. And so what does it do? Well, it keeps track of a couple of things. It will pull the response code from the URL connection. If there was a problem, if it wasn't HTTP okay, and actually that should probably be if it's not in the 400 range, but whatever. We will get the response message from the connection, which will basically be the error message associated with that error code, and store it away, and then we're pretty much done here. Otherwise, we want to read the contents of the response line by line, and we keep it in this content field here, and then you can use that content to get the response from the client. Okay, and then we trim off any white space so it's easier to work with. So that was an example of doing a get in Java. And actually, we're a little bit fancier than we were in the last screencast about keeping track of what the response is and what the error code is and stuff like that. With HTTP methods that pay attention to the body of the request, things are handled a little bit differently. Just like get, the parameters are URL encoded, but instead of being appended to the URL itself, they're written in the body of the request. So here's a method that does a post to a URL with a bunch of parameters. Again, we'll encode them, but this time instead of appending it to the URL, we'll open a connection to that URL. Say that we're doing a post, set do output equals true because we're expecting output to come back. And then what we're going to do is we're going to create an output stream writer that will write to the connection's output stream and code things as UTF-8, and then write the toString value of the URL encoded parameters. So here we're by writing to the the connection's output stream, we're sending stuff in the body of the request, as opposed to what we did for a get, which was to append it to the URL itself. And again, we'll create a response, the same response object. So the response doesn't care whether or not it was in reaction to a post or a get. It'll just read the response regardless, close the stream, and then return that response. And you'll be using this class in your project assignment. Okay, for those of you who have done HTML, you've probably seen get and post before. So the form tag in HTML, according to the HTML standard, can either do a get or a post. You can't have it do a put or a delete. Different user agents need to, well, not the user agent, HTML just doesn't support that. So here are two examples. Here is a form that would create a movie, and so it's going to be post, and or rather its method is going to be post, and then its input, like title and year, that will then be sent to the URL in the body of the HTTP request. The GET, on the other hand, this performs a query, searches for movies. It has several inputs, and these inputs will be put on the URL when you click search. In both cases, then the browser will render whatever it is the URL returns. Okay, so that's stuff that happens on the client side. Back on the server side, there are a couple more topics that I want to discuss. The first one is maintaining server-side state. So you guys probably heard of HTTP cookies, and cookies are little pieces of data that are sent back and forth between the HTTP request and the HTTP server to establish state between requests. So HTTP itself is stateless. You look at the spec for HTTP. There is nothing that talks about maintaining state between requests, but as the web developed, this was something that people saw were essential to do, right? You want to have a login session. You want to have multiple requests from the same user be correlated with one another. And so they put together a standard to discuss, or to describe these cookies. Here again, small pieces of data that are that basically the client associates with the server, and every time the client makes a particular request of a server, it sends not only the request but also all the cookie information that it has to basically say, oh yeah, right, I've kept track of these cookies for this server. Here they are, and the server can interpret it can interpret those cookies and say, oh, I recognize this user. I can recognize that cookie. I know what to do there. The Servlet API has a representation of a cookie in a class called, well, cookie. And cookies have things like a name that identifies the cookie and the value, and you can also specify the maximum age of a cookie. So cookies are created, well, are so much created by the server, but when the server is handling a request, one of the things they can send back is, oh, hey, here's a cookie that I want you, the user agent, you, the web browser, to keep track of. And the way you do this is you call add cookie on response. And then when a request comes in, the cookies associated with that request can be obtained with get cookies. Is anybody else getting hungry? I am. Here is, kind of hard to read, example of setting cookies in a servlet. So here I have a get, and it's going to do a couple of things. It's going to create a couple of cookies. The first one is going to keep track of is the first time that you hit this URL, the first time you visited this website. And I have a little helper method called getCookie, which we might see in a minute, which will get the value. I'm sorry, this is probably the getCookie method from the servlet itself. That will get the value of the first visit cookie. I also want to create a cookie for the last visit, or really the most recent visit. So if first cookie isn't is null, then we are going to set the value of the first visit to right now, and then it's kind of cut off here, but there's a comment that says, hey, this is the first time you visited this website, and the cookie is going to live for 3,600 seconds. I can't remember now the I can't remember the unit of the max age. And since I created a cookie, I'm going to add it to the response. If this isn't the first time that we visited the website, we are going to print out. So this is what gets printed in the response. Say, oh, hey, you've been here before. You first visited this web page on the value of the cookie, which is just the string value of that now, and then we will create a new cookie, which is which says the the last time for the cookie for the last time that you visited it, and we'll print that out too. Finally, we will sort of update the value of the last visit cookie with the current time, set its max age, and then add to the response. So if we go and run this program, let's see here, I think that's this one right here. Okay, so it says, welcome to the last, this is the first time I've hit this servlet. It says check your browser cookies. So let's go figure out how I can do that. Okay, and here are the cookies. So we've got cookies, here's the first visit, which is right now, and the last visit, which is, well, the same time, because it was the first time. And it says, let's see here, it expires at 3:32. Come on, let's make this a little bigger so I can see. So at 3 a.m., so that must be good for, what, 6 hours? Having problems doing math. 8 hours. Really? That's not what I would have expected, but whatever. And gosh, there's also these other cookies. I have no idea where they're coming from. So now I'm going to hit that page again by reloading. And it's telling me other things. It says, welcome back, because I've already been here. So the first time I visited was 7:32. The last time I visited was 7:32. That's true. But now if I look at the cookies again, you'll see that last visit has been updated by to 7:34. And that's what I get when I reload. So that cookie gets updated every time. Actually, maybe I'll keep those cookies up. Okay, so cookies are designed to only store a little bit of information. The protocol, there's a maximum size of a cookie, and it's pretty small, all things considered. So you can't store all the information you'd ever want to store about a user in a cookie. Actually, this is probably desirable. You don't want too much information about your user or about your application to be stored on the user's local machine. So there is there's an object in the servlet API called HTTP session, which basically represents, well, a session between the client and a server. And you get or create one of these with a get session method on a server request. So a request comes in and says, hey, give me the session. Like I said, it'll create one if it doesn't, if there's not one that already exists. And what a session allows you to do is to set key value pairs, object attributes basically, of that particular session. So you can imagine, the session comes in and, oh, you've gone and looked up who this user is, and you'll store information about that user in the session that your application can work with later. Now sessions live for as long as there's communication between the two, and actually sessions are underneath the covers are implemented using a cookie. Basically, there's something called a JSession ID that Java Web Containers. There's a cookie called that they then set, which basically says, oh hey, here is the ID of your particular session. And a session will last for as long as the server is up. Once you stop your server, the session goes away. The HTTP session is basically an object that resides there in your web container, And you can imagine that Jetty or whoever is maintaining a mapping between the JSession ID and then the session object. So this is nice. So that way it stays around. So even if it's been a long time since your user last logged in, as long as their session ID cookie is the same on the client, you'll be able to figure out who that is. Now, that being said, your application, you might want some logic on top of that to maybe you time out sessions after so much inactivity, or maybe you want to explicitly invalidate a session, like when the user logs out or something. So anyway, all of this can be managed. It can be can be managed by your application, by your servlets. So let's see an example of that. Okay, HTTP session. Okay, this is cool. Actually, let me get rid of. There we go. Here is a servlet that uses a session to store information about the about the times that you as a particular user have used this application. So here's information that you can get from the session itself, like the ID of the session, some big old ugly number, which is probably the JSession ID. Oops. JSession. Oh, which isn't here. Maybe it's there. I'll bring back the developer tools again. Oh, yep, sure enough, there's a JSession ID, big old ugly number. The session can also get the time the session was created, last time it was accessed, which I assume this is the 0 time, and then the max inactive interval, which means how long it'll live before it's automatically invalidated. Hide that. My application, my servlet, stores an attribute of the session called visit count, and as you can see when I reload this page, different things are updated, such as the last access time, and of course the number of times that I've actually visited. Oh, and here's information all about the cookies that are sent. As you can see, we still have first visited and last visited from our previous servlet, from our previous web page, and that's because, well, I never deleted the cookies. I never told the client, oh hey, I don't need that cookie anymore. So it still sends it. The browser still sends it. It doesn't know which cookies are needed and which ones aren't. Oh, and sorry, here's the JSession ID with, sure enough, big old ugly value. I have no idea what text wrap on is. It might be something that Chrome sends down. And here I have a button in HTML form that when I click it, it will tell the server to invalidate the session. And sure enough, yeah, there's no more session information there. You do find it a little strange that the cookie is still sent down, but that's probably well, actually, the client doesn't know that the session has gone away, so it'll keep sending the session ID. But if I reload this page, it'll establish a new session. Yep, there it is, with a different big old ugly number. Anyway, so that's the way sessions work. More all about the different HTTP methods. So there are some methods that are said to be safe, meaning that they only retrieve data and shouldn't have any side effects, shouldn't modify any server-side state. And these are things like get and then head-in options and things like that. Those are all safe. The HTTP methods that do modify server-side state or are expected to modify server-side state are put, post, and delete. These are said to have side effects. Now there's another way of grouping the HTTP methods, and that's into methods that are idempotent and ones that are not idempotent. So idempotent methods should have the same behavior no matter how many times they're called. So for instance, doing a get or a put or a delete, they always have the same effects, right? Get is just a query, so you should return the same thing every time, assuming that the underlying data hasn't changed. You get the drift. Put, which is like, hey, go, update the contents of a certain resource. The same thing, should happen every time. It should result in the same output and the same server-side state. And of course, delete, which basically means that if you try to delete something that isn't there, it shouldn't blow up. And what this means is that idempotency means that the responses to these guys can be cached, meaning that because I make the same query twice and I get the same results, I can cache that result, and maybe it means that I don't need to go all the way to the server to get the response. A post, however, is not idempotent, and this is why most browsers, when you go to do something like, oh, you've posted to a URL and you click reload, put up a dialog, put up a pop-up that scares the heck out of your grandma because it's saying, hey, are you sure you want to repost this data, et cetera, et cetera. Well, that's what it means. It's the server telling you, wait a second, I'm about to repost something. This means that you will, buy that second copy of Harry Potter on Amazon.com. Are you really sure you want to do it? So that's what idempotency is like in the real world. Okay, so all of this discussion about idempotency and the side effects of various HTTP methods and things like that is leading up to something called REST. So one of the guys that worked on the HTTP specification is named Roy T. Fielding, and he, as part of his PhD dissertation, formalized HTTP in sort of an academic way that turned out to actually have incredibly important practical applications into something called REST, or Representational State Transfer. Basically what REST does is it says, hey, I've got some application out in some thing, which is really the internet, and I'm going to expose that state as resources, and resources are essentially URLs. They're addressed by a URL. And then he goes on to say, resources are fetched and operated on using a different set of operations, which correspond very nicely to HTTP methods, and that these resources that are obtained by URLs and gotten through various HTTP methods are accessed by a stateless client-server protocol, which just happens to be HTTP. And, oh, by the way, some of the state can be cached. And so basically, the way I see this is that Fielding then sort of reverse engineered the web and put this very nice conceptual framework on top of it. And so he said, yes, the World Wide Web, it is RESTful because it follows, because it has these features. Well, what does this mean in practice? Well, let's say you've got some application out there, and it does something, right? It's got some data that it manages and exposes. It has services that you want to work with. Well, so you can expose all of that stuff by doing the following. Let's say you've got some data items that you're keeping track of, things like appointments in an appointment book, or phone bills in a phone call, or whatever. You need to assign an ID to each item of data. And then there are ways of navigating from one data item to another data item. You should use the standard HTTP methods, and we'll see in a minute there's a kind of a nice mapping between the methods and operations that you'd want to do in your application. You want to provide multiple data formats, meaning that your data should be available in HTML and XML and maybe JSON or as plain text or CSV or something like that. And then have stateless communication. It's really not so much about having a big long conversation between client and server. It's more like processing individual requests. And of course that helps at scale. So, as an example of this, let's say you've got a bookstore. You want to make every item in the bookstore addressable from the web. So each book would have a URL that would then locate it. Now, it's also perfectly fine to have URLs represent sort of different classes of items. So maybe all Java books, or all books that are published in June of 2008, or maybe all books that are authored by some guy named Fielding. This is another way to find items of interest. And then linking all together, well, you can use like maybe an XML format to say, okay, well, here's a book, and here's its name, and here's its reference, stuff like that. REST, if you look at the formal definition, talks about hypermedia. The whole idea is that if the data is linked, if the data is self-describing, then you don't need to worry about making your URLs very pretty. Interestingly enough, REST is not a formal specification, so there is a lot of well, difference of opinion. I think things have converged pretty nicely. But when it first came out, people were still trying to figure out, well, what are the best practices for REST? So you might see some REST APIs out there that look different than other ones we've been familiar with. So again, when doing REST, you want to use standard HTTP methods. So if you think about your CRUD operations for an application, that is create, retrieve, update, and delete, they map really quite well to the four most popular HTTP verbs. So when you want to do a create, well, that's posting to a resource. When you want to retrieve, that's a get from a resource. When you want to update, that's a put. And when you want to delete, well, it's a delete. Now, if the way that you're dealing with your REST API or the client to your REST API is HTML and you're using forms, and then you kind of got to break some of these rules because HTML forms only support get and post. And so then you'll also see that post is used to both update and delete data sometimes. It can also be, well, it also has to be used to create. And so like one way to express this is, hey, if you post to a URL and there's no ID parameter, then that'll create it. And if you want to delete, well, maybe you need to pass something in the URL, like delete equals true. However, let's face it, there aren't very many public-facing web services that let you delete data, right? You can't go to Amazon and start deleting books out from underneath it, stuff like that. And because get is safe, it provides an opportunity to cache it as an optimization, and then not only caching it for serving up the same content again, but also letting things like web crawlers, search engines, and stuff discover information that's there in your application. And finally, REST calls for providing multiple data formats, and so then you should let the client decide what kind of data, what format of data that it wants. And the way you do this is with the accept header to say, okay, well, this particular request, hey, listen, I want to get book 8743 from bookstore.com, and I want it as text. Or you could ask it for it as HTML and things like that. And this is nice because it means that the same application can communicate with both humans using HTML and computers using XML or something like that. And for practical purposes, you should try to leverage existing widely known formats instead of inventing your own, because you want your REST services to be used with a variety of clients, not just ones that are that you wrote. And of course, you should have stateless communication because, well, there's less overhead on the server, which means you don't have to maintain session state between requests. It also lets the server we might have a farm of servers that all provide the same functionality, and then some sort of load balancer in front of it to determine which server actually ends up fulfilling the request. And if you have stateless communication, it makes it much easier for a server to go down and not have it affect the client. Now, it's not always practical to have stateless communication. As a matter of fact, you have to have stateful communication if you want to have your web service be authenticated, right? Because the user's got to essentially log in, provide some credentials, and then every request you are passing some token back and forth to say yes, I'm authenticated. So yes, keeping around the login credentials, login token is appropriate, but you shouldn't have some big heavy application, right? You're probably REST services shouldn't be like a shopping cart where you're building up lots of stuff. They should be more simple than that. Something like a shopping cart should be the responsibility of the client to keep track of. So sort of conceptually, REST is a not terribly complex thing. And I hope that we've seen tonight how you can use Java's facilities for web programming to expose application behavior as a REST web service. So you need to figure out, okay, well, what behavior do you want to expose? And then write some servlets to handle requests. I've got an example there as a family tree servlet. We're not going to go into details about this in this class, but there's a very nice standard library called JAX-RS for Java APIs for XML-REST services, which provides a series of annotations and some other APIs that allow you to very easily expose data and behavior via REST. And I can, I'll leave it as an exercise to you to go read up on that. Okay, so in summary, what have we learned about Java web programming? Well, we learned about HTTP, the Hypertext Transport Protocol. This is what's used to communicate over the web, and it has verbs or methods like get, post, put, and delete. We saw a bunch of client-side code for working with URLs, for making requests, handling responses, things like that. But on the server side, there's an API called servlets that handle the web requests. And so basically it's an abstraction over HTTP, which provides nice Java APIs for dealing with your requests, your response, setting headers, getting content, working with cookies, all sorts of good stuff like that. Now servlets are deployed into a WAR file, a web archive, which is, servlets are compiled into a web archive, a WAR file, and then deployed into a web container. And Maven has some good support for working with not only WAR files, but also deploying them into various web containers. Finally, there is this formalization of HTTP called REST, which is used for defining so-called web services, actually pretty simple web services. It maps the HTTP verbs to the CRUD operations of your application, and allows you to leverage web standards, caching, all that good stuff. And Java servlets are a good way of doing this, and you'll see how actually you'll be doing it yourself as part of your next project assignment. Okay, so that's it. Thanks for learning about the web development in Java with me, and we'll see you next time on the screencast for Advanced Java Programming at Portland State University.